And what we are going to discuss today is natural language processing. It's the hottest topic these days, not in the form of natural language processing, but people understand more it as in the terms of Chat GPT, Gemini, Bard. There are a lot of large language models which have flooded the market. There are prompt-based generative AI like Midjourney, then Leonardo.ai, which allow you to create images from prompts. And yesterday, OpenAI launched Sora, which actually allows you to create videos even from text prompts, and that goes up to a minute. That means 60 seconds of video can be generated. And the entire periphery of generative artificial intelligence is basically based on one true understanding, that is natural language processing. That how do we speak, how do we give commands, how do we let the computers know what we want them to do. And if this could be done in the language that we know best, that means you might be Russian, you might be Chinese, you might be talking to them in English, you might be talking to them in Hindi, and they still understand. That basically is the aim of natural language processing that we are going to discuss today. So let me share my screen quickly for the presentation that we have. It might be a little longish presentation, depends on the questions that you would ask. So, but please feel free to ask the questions, because that is the purpose of the workshop, to make sure the faculty from different institutions can keep on benefiting from the series of workshops that we are bringing here. So we'll discuss certain challenges for NLP and some tool set that we are using. So there was a very long introduction by Manmohan sir, but thanks to the teaching community who have actually inspired the new titles, because I feel I am writing as a teacher. I am writing in the domain of artificial intelligence for the teachers themselves first, and then only for the students, so that the teachers understand what is the nitty-gritty of the subject. The challenges which I faced while learning AI, I'm trying to make them easier for the other faculty members. That is the basic purpose. So we are going to discuss what is NLP. Also discuss what it is considered not, why is it such an interesting, such a challenging field, how NLP relates to other fields including AI/ML, and what typical NLP applications and tasks are. What is the pipeline of developing an application in NLP? We run this workshop across two sessions. Today we are going to discuss the concepts, that what are the different concepts in NLP, and the next session, whenever it happens, that would be conducted on a complete practical aspect of everything that we are going to discuss today in the pipeline, using Python, that how do we pursue those tasks. So originally, when we were communicating with the machines in 50s to 70s, all those computer science fraternity who are attending the session, they know that we started out with punch cards. Punch cards were perforated sheets on which we would put in a series of holes, which a punch card reader would be able to read. From that, we have come a long way to now allowing instruction to the computers in the forms of programs that we have developed, languages since Basic, Pascal, COBOL, moving on to C++, Java, Python, lot of web, and so forth. But today, we actually talk of the communication with machines in the term of, can we speak to the machines in the language that we know, that I need a dinner reservation for two for Valentine's Day, and your computer or your digital assistant can understand that, and they can respond back to you in the same language that you are telling them. That is what NLP brings to the technology spectrum. So talking about a technical definition, NLP is a principled approach to processing human language. It may be any human language. Formally, we can define it as a subfield of artificial intelligence, which refers to computational approaches to process, understand, and generate human language. So far, we have discussed data science. Data science was the subfield of AI that would discuss computational approaches for processing numerical data or structured data. Then we discussed computer vision. That was actually again artificial intelligence applied to images or videos. And this one is about the human language. Can we understand and can we generate human language using artificial intelligence? It is a part of AI because language processing is a huge part of human intelligence, and you will see why and how. I'll require you to participate when I'll have a very small question in the middle of the session, and I'll ask everyone to participate. So, natural language processing speaks about natural language as compared to what? The first question which I actually asked myself, searching through all the literature, that why NLP explicitly mentions natural language processing. What does it mean for a language to be natural? To me, English is natural, Hindi is natural, whatever languages that I understand, they are all natural. So, are there any unnatural languages, or what is more natural? Spanish or French or English or Hindi? I would not find the answer to this. But the comparison came in the form of that the languages can be formal, where there is a specific syntax, there is a specific grammar, everything is predefined. So all the languages humans speak are natural. Formal languages, on the other hand, which are invented by humans and have been strictly and explicitly defined syntax. That what is the grammar, if we want to say something, and what does that mean? What is the semantics of that? If you have any queries during the session, I'll be keeping an eye out on the chat box. So submit a query. I'll be very willing to answer that wherever during the session it happens. So with formal languages like C, C++, Java, any programming languages that you have been working with, you would find that the syntax is fixed. You would write the for loop in the same way. It would be written every time. And the result of that would always be same. So if you say var a equal to 20, that it would be written that way, and it would be understand that we are declaring a variable a which is having a value of 20. So syntax and semantics both are absolutely well defined, structured in a formal language. But what about the human languages? Are they formal? Can we formalize? So you'd be surprised to know that the only language which comes closest to being a formal definition where the syntax and semantics are very clearly designed, that there is no ambiguity or there is a very little ambiguity, is Sanskrit. So all those researchers who are working in the domain of NLP, you'd be surprised to know again that Germany is leading NLP research into Sanskrit language because they consider Sanskrit is very suited because of the syntax and semantics being very well defined as compared to any other language that we use. So going ahead into it, programming languages are defined in such a strict way that it's always clear what is grammatical and ungrammatical. This is not the case for human languages. Human languages are ambiguous, that their interpretation is often not unique, and you will see with an example how. So when I say as a sentence that he saw a girl with a telescope, who had the telescope here? That did he see the girl with a telescope? That means was he using a telescope to see the girl, or he saw a girl and the girl was carrying a telescope? There is no correct answer here. You would not be able to say that this one is correct or this one is correct. Yeah. So both the I hear somebody. I would request please put it in the chat box so that I can answer it. I'll certainly look at it. All right. So two interpretations of the same sentence are there. That one goes like the girl with a telescope is one, or he saw the girl with a telescope. That means he was using a telescope to see the girl. Both of the interpretations are correct. It would, if we get more context, that while he was standing on the roof of his house and the girl was far that could have added more information, and that where could have anticipated that this might be more close to what we are referring to. But in this sentence, there was no clarity. It was ambiguous that which one works which way. Similar to this, there is syntactic ambiguity. This is something that we call as that we do not know the phrase with the telescope, who is it about? That we do not know that this prepositional phrase is modifying which specific subject. So this is called a PP attachment problem in NLP, in English also. It's a classic example of a syntactic ambiguity. So I define a syntactically ambiguous sentence as one which has got more than one interpretation of how the sentence is structured. So you can interpret the sentence in different ways depending on what structure of the sentence do you believe. So that is always followed here. There is another kind of ambiguity although that talks about semantic ambiguity, that says this sentence is syntactically correct. I saw a bat. Okay. Its sentence has a very clear structure. Out of all these, which word or words do you feel can be ambiguous? This I would request you to put in the chat box. Which word can be given two different meanings or more than two, which would make the sentence ambiguous? Let us look at it. Okay. I get an one bat. Archana says bat. Sony says bat. I saw a bat. What can be the different meanings of bat? Can be a cricket bat or that mammal bat that flies, right? Any more? Anything else? I see a lot of participants. They can put in their opinion. I would love to have it because there is more, certainly. Okay, let's take it forward. It's not just about the bat. I may have several different meanings of these sentences, like saw can be the past of see. Saw can also be cutting something with a saw. So given that saw can be ambiguous, there can be two meanings for saw and there can be two meanings for bat. There would be total possible four different meanings for the same sentence that we have. So this is semantic ambiguity, that what do we understand of this sentence? Does this sentence mean that I observed a nocturnal flying mammal? Did I observe a cricket bat? Or I cut a baseball or a cricket bat into two? There is more ambiguity there, that the bat may refer to a baseball bat, a cricket bat for that matter. Or it can be even cruelly that I cut a nocturnal animal with a saw, and that is another possible representation of the same sentence. This is called semantic ambiguity for here. So artificial intelligence, machine learning, deep learning, these we have all covered prior. But natural language processing goes into all three domains. Major part of NLP comes within the domain of artificial intelligence without having to require to apply ML or deep learning. But learning is a process which would depend on the kind of data that we have, and deep learning and machine learning also contribute equally well to NLP as a domain. So NLP is being used in a lot of applications these days. You have seen conversational agents like Siri, like Google Assistant, like Alexa from Amazon. These agents contain speech recognition. They can analyze your language. They can process dialogue. They can talk back. They can retrieve information from several sources, and they can convert text to speech. That basically is the purpose of them. Then another example is machine translation, where you can translate any piece of text from one language to the other. So you may not be knowing Chinese at all, but if you are coming across some text which is in Chinese, copy it, paste it to translate.google.com. It would automatically first detect what language it is, and then you can choose the language, or it would be automatically giving you the language which you usually prefer to work with. So that is another application of NLP. So the applications are endless. You can have machine translation, retrieval, question answering, dialogue, chatbots, summarization, sentiment analysis, and a lot. But we'll be discussing the core technologies that apply to NLP. today with an example, of course. So we are going to take an example which contains the text something like this, that London is the capital and most populous city of England and the UK, standing on the river Thames. You see there is some text. That text contains certain parts. How would we take the text, apply NLP to it? For that matter, any general text, how do we apply NLP to it? What are the various steps that we have to follow? That is going to be the part of discussion. Followed by that, there are more challenges to NLP that we can think about. We discussed of certain challenges, that there is ambiguity, syntactic and semantic both. There are a lot of languages people speak. There are a lot of dialects also people speak in different languages. That is another matter. So let us teach our computer the most basic concepts of written language. The first out of them would be sentence segmentation. That this is a paragraph. We are actually processing a paragraph in piecemeal way. That we'll pick one sentence, understand its meaning. A sentence basically is defined in the English language as a coherent coherent collection of words which has its own independent meaning. So each of these sentences would have its own meaning. We can start by segmenting the sentences or break the complete text into different sentences. For instance, it would give us three different parts. London is the capital and most populous city of England and the UK. Second sentence is standing on the river Thames. And third sentence, it was founded by Romans. So this is the first part of any process which begins with the pipeline of NLP, that you break the complete text into sentences. The second part goes into word tokenization, where we start tokenizing the words, or we start breaking the sentences further into different words. Now, this is required because what we are looking at is that we need to understand what constitutes this sentence. The sentence had a meaning, understood. We understand the meaning, the computer does not. So in case we want the computer to be able to understand what is the meaning of a sentence, it has to actually go through the process of breaking that sentence into parts. And that process is something that we call as tokenization. Now, tokenization is not defined. I mean, different people use different ways of tokenizing, but so far as we are concerned, we'll just keep the information general as that. Let us break each of the word separately, right? So that may contain punctuation, that may contain any part, that may be apostrophe, whatever is coming in the sentence, we are breaking each part separately. So after yes, is there? I don't see a question. Can we have the audience muted in case? Okay. So the next part, after we have broken our sentence into words, we need to understand the parts of speech for each token. Right. Ashish ji, you have the command. There is one. Okay. Thank you, Tamil Selvi. So we look at each token, that we broke the paragraph into sentences, the sentence into words. And now we want to understand that what does each word represent? Is it a noun? Is it a verb? Is it an adjective, or so on? Because knowing the role of each word will help us figure out what the sentence is talking about. Who did what to whom? That we need to understand what are the parts of the sentence. Like, so here the input word may be London. The surrounding words are also there. Is the capital. The part of speech prediction model translates it to that's a proper noun. We need to take this exercise forward for every single word that's coming into our text. There would be two important things here. That are we going to apply this to everything that's coming into the text, because the text might be huge, that there might be some only important information coming in certain words. There might be some words which have got absolutely no important information. What do we do about that? But after breaking the paragraph to sentences and sentences to words, the very logical next thing to do is to identify that what do these words mean, whether they are a noun, verb, adverb, their currency, there may be money, they may be percentage, they may be anything. Okay. So the next step is lemmatization, that we would be converting the word into a lemma form. There are two approaches here. I'll discuss the second one later. But the first is that I had a pony and I had two ponies. Both of them talk about pony, but they are using different inflections. When computer is working with the text, the computer needs to know that which is the base form of each word. So the computer understands that both of these sentences are talking about the same concept. So otherwise, they look totally different words to a computer. Now, in NLP, we call this process as lemmatization, finding out the most basic form of a word that we are using. Most of the text that we are going to read would also talk about stemming. Stemming allows you to create the base form of the word, but as a stemmer operation. So, majority of the approaches you will find stemming and lemmatization both are used, but both of them have a different purpose. Stemming is used when you have a very large amount of text and you do not want to search the corpora or the complete database for the base form of the word. You just actually bring it to stem form by an algorithm like Porter stemmer, or there are several algorithms. Lemmatization is that whatever word we are trying to lemmatize, it would compare it with the complete corpus and check out what is the base form of the word, or multiple words if they are appearing. So lemmatization is computationally very expensive operation as compared to stemming. So when our database is huge, we would first apply stemming and then apply lemmatization. But when we have a small sentence, we would naturally skip the stemming operation anytime that we would require to work with. So the fifth step is identifying stop words. We would have to also see that the words which impart no useful information, no information is conveyed by those, they are appearing very frequently. So we can filter out those words here, like you may remove and, the, a, because when we are doing on statistics on test, these words introduce a lot of noise because they are appearing way more frequently. So if I am trying to find out which words out of my text are most important, like London or capital or United Kingdom, I would be able to do them on a basis of some statistical analysis and something like that point POS tagging. But with the ands and the, then a, then a lot of ands, that they add a lot of noise. So statistical frequency of the words which are important is lost in the process. I see a question on the chat. Okay, Archana, I have just removed that. Thank you. All right. So when doing statistics, the stop words add a lot of noise because they are appearing way more frequently than other words. So looking at the sentence that we had, initially the first process was to find out what is the POS, that part of speech each word is representing. Oh no, first step was break the paragraph into sentences, sentences into words, then start understanding the words as individual. So within the first part, what we did was we broke it into part of speech. In the second part, we see we are applying lemmatization even with verbs, that be right. In the third part, we are actually trying to find out which words are the most significant. See, where I have highlighted London is in dark, is, the, and, most. These might be the stop words that we do not attribute, that they are going to give us much more information about what we are looking forward to work with. So these words can be skipped very safely when it comes to natural language processing. All right. Then the next logical step is dependency parsing. Dependency parsing allows us to see how all the words in sentence relate to each other. That means some word would be dependent on the other. The computer understand it more in the form of a tree which assigns a single parent, that this is the word which is the most important, which is the root of everything, and you have to understand the complete sentence with context to the parent word. So root of the tree will be the main verb in the sentence. So our past tree will look something like this. That is, the verb is the most important or the root word, and based on this root word all the other words are understood. So this is dependency parsing. In addition to creating a tree, we might also want to label the tree as that what is the part, that this verb, which is the subject to this verb, what is the attribute that it is working on, what is the conjunction it is applied with. So we see a lot of work happening beyond the scope of, I'm not a linguistic, I mean, beyond the scope of computer science people, the linguist, computational linguist actually worry about that what are the parts of speech, how do they relate to each other. Okay. So moving ahead, the past tree shows us that the subject of the conversation is noun London, right? That coming from the subject. Then you can also see it has a B relationship with the capital. So London, B, capital, these three things together give us something information useful, which says London is a capital. All right. So London is a capital is available from this verb, the subject, and what is the attribute of this specific subject. So London is the capital is one. But if we go on further, we would also be able to analyze from this. If we go the complete past tree, it would also tell us that London is the capital of United Kingdom. As we begin with the sentence, this was what we started out with. I'm taking you back to the text, right? So London is the capital and most popular city of England and the United Kingdom. So if we'd have made a complete past tree, from the first sentence, we would get to know London is the capital and it's the capital of United Kingdom. That would also be apparent from the past tree that we have made. I hope so far there are no questions. All right. So we can try dependency parsing. I have just got a sentence. This is, I'll put in the chat window for you so that you can also try at your own work. I have shared the link. So to this, we can give any sentence. The sentence is syntactically and semantically correct. It may be wrong as from the perspective of correctness, truth. So you see that a dependency parse allows us to start from a root, and it also identifies that which verbs, which preposition, what attribute. The subject is Delhi, the attribute is the most populated city, and so forth. You can try this out on your own for any sentence, and it would work perfectly as the way it is working here. Okay. Then goes into with the dependency tree that we created. It is not just a noun, it is actually a complete phrase in itself. It is giving the meaning to the, so city, the city which is populated, the most populated city, they are all actually built around the noun called city, and this is allowing us to understand more about this noun. So we do not worry about only the nouns, but we can club the noun phrases together. So most populous becomes a phrase, and like that. So we can find out noun phrases like this. So London, B, now the capital and the most popular would be group, the noun phrases. So most popular city, instead of being adverb, they become a noun as a phrase. So this step would be optional. Sometimes we may do it, sometimes we may not do it, sometimes we want more detail, sometimes we do not want as much detail. So this may be an optional part of dependency parsing, but we do sometimes do this. And this is something that all of you must be familiar with. We then apply a process of named entity recognition. NER, before NER, whatever we were doing was we were breaking the sentence into parts, trying to understand, figure out the meaning of each of the part of the sentence as the part of speech, then try to give it a meaning with dependency parsing. But with named entity recognition, this is something coming out of machine learning which allows you to classify that the word which you are looking at belongs to which class. Is it a country? Is it a place? Is it a person? Is it some currency? So this is something which allows us to find out that what each word of the text that we are giving, what entity class does it belongs to. You may see the entity classes as like uh, people's name can be entity class, company name, geographic location, product name, date, times, amount of money, and names of event. They are kind of the entities that we have in any machine learning, any NLP approach. So let us look at another example that you would be able to see. I'll put the demo for this also in the chat window. But this works like post any content here, choose what entity labels do you want to find out within this text, choose which model are we applying. So it works across several languages, and then click on search. It is going to identify, see 1991 was the date, then India, the country. Second is an ordinal kind of data, so ordinal or different kind of statistical data that we are dealing with. Then 5.5% is percentage. Then a lot of things that it can actually immediately identify from the text. Give it a different text, it would be able to identify which entities do the text words belong to in each of these parts. All right, let me put that back again in the chat window for all the people out there. Okay, so you can test this again and let us go ahead. The last part is co-reference resolution. That okay, we'll just simply understand the sentence. English is full of pronouns, word like he, she, and it. That if we can always keep a track of what these words represent, but computer cannot. For an example, the third sentence in our document says it was founded by Romans who named it Londinium. Now the problem is that we do not have context. The prior context, the first two sentences had their own context, but unless and until we understand what are we talking of when we say it here, we would not be able to understand that this is talking about the capital city London. So it would be a lot more useful to know that London was founded by Romans. So this, as a human reading this sentence, you'd be able to easily figure out that it means London, but computers do not understand. So co-reference resolution is a way of computers to be able to understand. And there are a lot of, this is the one area in which maximum large language models work, that how to interpret what is more important in the context of what we are looking at now. So we want to figure out all the words that are referring to the same entity using a co-reference. Correct. So you can say, looking at that, it was being used first time after speaking about London. The co-reference model would be able to understand that it is being used in conjunction with the text called London. Here is my complete pipeline for natural language processing. We talked about that take a text document, segment the sentences, tokenize it, complete a part of speech tagging, then lematize stemming, remove the stop words, do a dependency parsing, join the noun phrases as a part of dependency parsing again, perform a named entity recognition, and then do a co-reference resolution, which is going to give you a parse text which you are going to work on. Right. This is the complete pipeline. We haven't looked at the code yet, but we will certainly. But there are challenges that how do I segment the text into words is a problem. Words with multiple meanings is again another problem that we saw in the previous example. Some words have a very specific domain meaning, like latex. Latex can represent rubber. Latex can also represent a programming language. So depending on the context, the word meaning would differ. Then there are multi-word expressions which have a different meaning, make a decision or take out or make up. Now make would have a different meaning unless and until it's used in conjunction with make up. Or take would have a different meaning unless and until it is used in conjunction with take out. So these are some challenges that we have more with NLP. Then there is a challenge of unstructured data. Majority of the information which comes in text is unstructured. Machine learning, artificial intelligence, on the other hand, it feels easier to work with structured data. What if we could put something like all unstructured data into tabular format? It would have been so easy to work it out. Then part of speech tagging, we just read out that we understand which part of the speech was noun, which was pronoun, which was adjective, which was adverb, everything we understood. Look at this. Would you be able to actually understand which part of the speech are we talking about? This is the language which my daughters speak in. I hope several of you are also aware. So this is something that I call a Gen Z. It's very hard to understand what it even means. I'll make things simpler for you, for those who are not acquainted with it yet. It goes something like IKR is, I know, right? Shaking my head, SMH. He asked for your last name so he can add you on Facebook and laugh out loud. This is what the sentence is going to look like when we convert it to from Gen Z to our language that we are used to working with. And then we can see it's an interaction or an acronym or a pronoun, verb, preposition, determinant, adjective, noun. No, we could now convert. But NLP has this challenge that this lingo keeps on changing. Sometime back, there used to be a different kind of language. Now this is there. Maybe in the future, some generation may come up with a language of their own, which we do not even understand what they are talking about. So every time something new comes, NLP has to understand that. That is again a challenge. Then expressivity, that it's not that ambiguity was the only problem. Sometimes it happens that the same meaning would be conveyed by multiple sentences. So she gave the book to Tom versus she gave Tom the book. Both of the sentences are correct syntactically, semantically, and both have the same meaning. But the computer must know that both of the sentences have the same meaning. For some kids popped by versus a few children visited, generational gap again. The sentences are meaningful, both are same. Is the window still open or please close the window is again the way how we are going to say things. So expressivity is again another problem with NLP that is following. And NLP is changing a lot with the landscape now that with the increase in computing power, NLP is benefiting a lot. Web rose, there were a lot of documents online. Then the social media added much more data with videos, audios, text, podcast, and so many things. Machine learning is advancing very fast. And we also have started understanding languages in social context. So that is changing the NLP landscape. It is coming to the forefront. The chat GPT or Bard or Gemini or the other tools, they are making revolutionary changes to how we have been using NLP. Even in fact, the video generational or image generation tools are also working in the same domain. I'll just give you a sneak peek of what we are going to work with in the session which is going to come up next is we'll take up a database of words, text for that matter, and we are going to work in a complete workshop on how to import data from a text, how to apply the different operations of NLP which you have just. So we'll take up raw data, we'll apply different operations on the data to understand whatever processes of NLP that we have discussed today with an example. Time bound, I'll be having to finish this session in another 5 minutes or so, or maybe 10, depending on whatever query that you wish to ask. So I am throwing the floor open for any query that you may have related to the presentation so that we can discuss them. You can post your query in the chat box, or you can actually I had just seen that part of it was covering, so I hope we resolved that problem earlier. Please come out. NLP is hard. NLP is not as easy as usually people believe. And I personally feel that data science, machine learning was easier. Computer vision was a little understandable because we could see all the aspects of images, that these are the features. Text is the hardest to work with because the features are something that we are so acquainted with that we do not even consider it a feature. And text is the hardest to generate also, because teaching computer how to understand is still fathomable, but teaching a computer how to speak the language that we speak was even harder, because while teaching we were removing stop words, we were removing punctuation, we were removing everything, we were simply giving it the most important part. But while generating, it has to put all of those things back with the context that it is generating. So that is even a harder point for it. I think if there are questions, then I'm still keeping the window open. 5 minutes down the line, we'll be closing the session. Any question on NLP is welcome. Not even, it might not have been covered in the presentation, we'll still be able to help. Any questions on YouTube, sir? If there are, can you please post them here? All right, that's my time. I believe that the session is complete. We'll meet again for the practical session alternately. Next week, I'll be busy. Next to next Saturday, we are going to cover the remaining part of NLP with a complete corpus and apply all the processes to it using NLTK. Understand what NLTK library works like, what are the different operations, and how do we apply them.
Many thanks, Dr. Gupta, for another informative and engrossing session. I would also like to thank all the participants to today's webinar. As Dr. Gupta said, we'll soon be having another session about which you'll be duly notified. Have a great weekend ahead. Thank you.